The second type of calculations or conversions is calculating the energy of light, either from frequency or from wavelengths. Frequency energy conversion is done using that form of Planck's formula, and wavelengths energy calculation is done using that form of Planck's formula. Let's do the first one, calculating energy starting from frequency and vice versa. So if you know that the frequency is 9.23 times 10 to the power 14 hertz, what would be the energy? First step is going to be choosing the equation that you should use, which is Planck's formula, energy equals h nu, and then solve for energy by putting the value of h and the value of frequency into the equation. Is going to equal 6.63 times 10 to negative 4 joule second times 9.23 times 10 to 14 second minus 1. You can clearly see that second will cancel out with second minus 1, and you will get the energy in joules as expected, which should be that value here. But if you track sig figs, you only need 3 sig figs. So you round it to 3 sig figs, and that's the final answer. Second type of conversion is going to be finding energy from wavelengths. It should be very similar to the previous one, and we can do it in two ways. We either do it by going from energy to frequency to wavelengths, or by going from energy to wavelengths directly using the equation E equals hc over lambda. So let's do it step by step first. So the first step is going to be converting wavelengths lambda to meters. So you start with the wavelengths and multiply it times the conversion factor, and you get the value in meters. Second step is rearrange the frequency wavelengths relationship to solve for frequency. Frequency should equal speed of light divided by wavelengths lambda. You put the numbers, get the frequency, and it's going to be that value here in hertz or second minus 1. Fourth step is going to be using Planck's formula to move from frequency to energy. And that's the value that you should obtain. And if you round it to the right number of sig figs, it should be 3.98 times 10 to negative 21. For question B, that's basically repeating the same 4 steps and get the final answer of energy in joules. And in this case, it's going to be that value right here. But as I said, we could probably save a little bit of time if we don't do it step by step. If we do it directly using this form of Planck's formula, we can directly find energy to equal h, 6.63 times 10 to negative 34 joule second times the speed of light, 3 times 10 to the power 8 meter per second, and divided by the wavelengths in meter, which is 5.00 times 10 to negative 5 meter. You can see that 1 over second is going to cancel out with second, meter is going to cancel out with meter, and you will get energy in joules, which basically should be the same number, 3.98 times 10 to negative 21 joules. And we can go the other way around, which is finding wavelengths from energy. So if we have a light with the energy of 217.64 kilojoules per mole, what would be the wavelengths? First step is going to be converting energy from kilojoules to joules. That can be done using the SI prefix to get the energy in kilojoules per mole. And then second step is going to be finding the energy of one photon. And that's going to be done by dividing by Avogadro's number to find the energy of one photon with this value right here. Third step, rearrange Planck's formula to solve for frequency. So that's Planck's formula. You rearrange it to solve for frequency and then plug in the numbers, the energy that you calculated in step 2, divided by Planck's constant, and that should give you the frequency in second minus 1. And step number 5, so the equation of the speed of light, it equals lambda times nu, rearrange to solve for wavelengths. You will get that form and plug in the numbers. So it's going to be speed of light divided by the frequency you calculated in step 4, and that's going to give you the wavelengths in meter. And if the question is asking for other units, you could probably convert it to nanometer using the SI prefix, and that should be the final answer in nanometers.